Welcome to my YouTube channel. I hope you guys are having a wonderful weekend. In this video, we will look at problem 729 from Leetcode. So let's look at this problem. So this is another problem where I think we have two more similar problems in this series, my calendar. So I will talk about those two other problems in the upcoming videos, but let's look at the first problem in this series. Okay, so here is the problem, and as usual, just try to come up with a pseudocode for this before we look at my solution together. So approach one is very naive approach, something that I think this is something that we all should try to come up with. So basically, remember, we have to. So in this case, we are looking at under what situations do we have overlapping intervals, like overlapping schedules, right? In this case, and then list out all the possible cases. So in this case we have 4 cases. Here we have 1, 2, 3, and 4. And so start and end, this is something we already have in our schedule, and this X and Y, this is new schedule that we are about to book, and we want to know if these two are overlapping or not, right? Oh, and actually this one should be, I think this one is closed. This one is close too. Yep. Anyway, so that's for that. And we have 4 cases, and under 2 cases we have overlapping schedules, right? There will be the first one, this one, and then the third one, right? And can you find the condition for these overlapping intervals? So there will be this: if start is less than y and x is less than end. So if you apply this, if you think about this one, so start is definitely less than y, and then x is definitely less than end, and the same here, start is definitely less than y, and x is definitely less than end. So because of this, we can just we don't have to write if, else, like those kind of statement. We can just check this statement only once, and then that should simplify this code a lot. So here, instead of writing if and else if statement, just use this one, and then that should take care of this problem. So that is the first approach, and let's look at the code for the first approach. So as you can see, this one is very simple. We just basically we'll be running this self calendar, iterating from the first all the way to the end. Hopefully not, but if, and then we check that we check this condition: s is less than end and start is less than e. If that is true, then that means we have a overlapping schedule, so we return false. Otherwise, we do not have overlapping schedule, so we append current schedule, start and end, to our calendar, and then we return true. So I think one thing that you have to keep in mind is that this problem doesn't mention this. I missed this somewhere, but if you look at here, 10, 20, 15, 25, 20, 30, if you look at the first element, it is increasing. So yeah, I think that's something, maybe this problem didn't mention this, but it's something that you have to keep in mind. So that's the first approach. This one is the time complexity for the worst case would be n squared. So well, I think I tried this approach first for fun, and this one passed. Actually, this one passed. So yeah, and now we think about this one. Whenever we have a sorted array, or in this case we have sorted tuples, because I use tuple here, and then if we have to find the position there, what should come to your mind? Instead of enumerating all this self.calendar, that will take too much time, we can use binary search, right? Binary search will be log of n, so that's extremely fast. So we should think about using that. Oh, and before I move on to using binary search, you could use what is it, what is it, sorted counter. You can use sorted list, and so you can do that. yeah, I think the library is called sorted containers, but I'm not so sure if that is allowed like in the interview setting. So if that is allowed, this problem should be much simpler. Like I think the second problem in this series, I used sorted dictionary from sorted containers. So that's something that you have to check with your interviewers and see if using sorted container is okay or not. So if you look at my second approach, I just didn't use like sorted containers for Python. So anyway, so that's for approach 2, it is pretty much the same thing. We would be, so suppose we have more than two schedules. I mean more than two schedules in our, what is it? I used calendar. So suppose we have more than two schedules in our calendar and those are not overlapping. So let's first think about like cases here. So we would have three cases here. So this start and end is something that we are thinking about adding it to our calendar, and we want to know if there is overlapping section. Of course, you can just check start. If start is less than E2, then we know that they are overlapping, so we return false. Or we can also check if end is bigger than S1. If that's the case, then we return false because those are overlapping. And then this red one is like you don't need to check this because these two cases will take care of that. So I think you can use binary search. Like you can import binaries. I think you can import bisect. I think that's the module, and you can use either bisect underscore left or bisect underscore right. And yeah, it's pretty much the same with, so this is the code and it is almost the same with this one. Like just instead of we have a for loop, we have a we have a binary search here. And I will have a detailed videos on binary search because I think that one is a bit tricky. Like, so here I'm using bisect module, but I think you should know how to write binary search without using this module. So that's something that I will talk about it, and I will talk about this approach in more detail, why I have like index -1 here and so on. So I will do that for the next video, and let's look at the code and see what we get. Yeah, so I'm really surprised that this one actually passed the Leetcode. So I wasn't expecting that to happen. So here is the code, and let's try run the first approach, the naive one. So let me comment this section and let's uncomment this and see what we get. Yeah, I'm genuinely surprised that this one even passed the code. The worst case is n squared, so I didn't expect this to pass. But let's run binary search. Binary search should be a lot faster. Actually, you can just you can combine this, so you can use if this statement or this statement, then return false. But I think you guys should know that. So let's run this. It should be a lot faster. Very surprised. I'm very surprised that they are almost the same. But anyway, well, that's for this video. If my video helps you guys understanding this problem, please give me a thumbs up. You can write a comment, and I will have a separate video on this binary search. Like this one is, I think, really tricky part. If you don't know the history, like there is one computer scientist, he found so many people not able to write correct binary search, and he himself couldn't write a binary search like correctly. So I think that one is, binary search is a bit tricky, but it is super useful. So yeah, I will talk about these two problems. They are also interesting, and I really like those problems. And then I still haven't forgotten I haven't forgotten about numerical linear algebra. I will talk about that one too. Yeah, and so that's for this video. I will see you guys next time. Okay, bye bye.